So in this lesson, we are going to apply mesh analysis to circuits involving current sources. Now, in analyzing circuits with current sources as far as mesh analysis is concerned, we have two major cases that we need to look at. Now, the first one is when a current source exists only in one mesh, we simply set the mesh current to the value of the current source, or better still, the negative of it, depending on the direction of the mesh current and the direction of the source current. Now let's consider this particular circuit. In this circuit, you realize that we have a current source only in mesh 2. We have a current source which is 5 amperes only in mesh 2. Now in this case, the idea is to set the mesh current, which is I2, equal to the value of this current source, or the negative of it, depending on the direction of I2 and then this 5 amperes current source. Now you realize that for I2 we are taking the clockwise direction, so we have the current moving in this direction, and then we have the source current also taking the anti-clockwise direction. Now since we have the two currents opposing each other, then we simply set I2, which is the mesh current, to be equal to the negative of the value here. So I2 is equal to negative 5 amperes. So whenever we have a current source existing for only one mesh, we simply set the mesh current equal to the value of the current source, or better still, its negative, depending on the direction of the mesh current and the direction of the source current. Now let's move on to the second case. Now for the second case, when a current source exists between two meshes, we create a supermesh by excluding the current source and any elements connected in series with it. Now let's look at this circuit. In this circuit, we have a current source 6 amperes, which is found between two meshes, that is mesh 1 and then mesh 2. Now what this primarily means is that because we have this 6 amperes current source being shared between two meshes, then we simply create a supermesh. We simply create a supermesh, that's by excluding this whole branch, excluding the current source in series with any other element. So we are going to redraw this circuit such that we have the 20 volt source, we have this 6 ohms resistor, and then we have the 10 ohms resistor, and then the 4 ohms resistor. So by drawing the supermesh, we exclude the branch in between the two meshes, the branch which is made up of the current source in series with any other element. So this new diagram is called the supermesh. Now, in as much as we eliminate this whole branch, we still have the idea that we are working with two mesh currents. So we still have I1 and then I2 in mind. So we can apply KVL to this supermesh, and then we know that the source voltage is equal to the sum of the voltages dropped across the loop. So applying KVL to this particular supermesh, we have 20 equals. Now if you consider the first diagram, you realize that we have I1 flowing through the 6 ohms, so that's equal to 6 I1 plus, considering the second mesh, we have I2 flowing through 10 ohms as well as 4 ohms, so plus 10 I2 plus 4 I2. Now let's try to simplify this. So we are going to have 20 equals 6 I1 plus, we have 10 plus 4, which is 14, so 14 I2. We can divide through by 2 so that we have 10 equals 3 I1 plus 7 I2. Let's call this equation 1. Now again, we are going to apply KCL at this node, especially at a node where we have the branch which intersects the two meshes. So with this, applying KCL, we know that the sum of currents entering the node should be equal to the sum of currents leaving the node. So we have current I1 and then 6 amperes leaving, and then I2 entering. So we have I2 to be equal to I1 plus 6 amperes. So let's call this equation 2. Now we are going to put equation 2 into equation 1. So we put equation 2 into equation 1, and then we have, for equation 1, we have 10 equals 3I1 plus 7I2. In place of I2, we have I1 plus 6. I1 plus 6. So let's expand the equation. We have 10 equals 3I1 plus 7I1 plus 7 times 6, we have 42. Let's transpose 42 to the left hand side. So that becomes 10 minus 42, which is equal to negative 32. And that's equal to 3 plus 7 is 10. So we have 10 I1. Therefore, we have 10 I1 equals negative 32. We divide through by 10. And then we have I1 equals negative 3.2 amperes. So this is the value of I1. Now from equation 2, we can find the value of I2. So we have I2 to be equal to I1, which is negative 3.2 plus 6. And then negative 3.2 plus 6 is equal to 2.8. So we have the value of I2 to be equal to 2.8. So basically that is how to consider circuits involving current sources. Now the first one is, if you have a current source existing only in one mesh, then we simply set that mesh current equal to the value of the current source or the negative of it, depending on the direction of the mesh current as well as the current source. And secondly, if you have a current source existing between two meshes, we create a supermesh excluding the current source and any element connected in series with it, and then we apply KVL to the supermesh, and then we apply KCL at a node in a branch where the two meshes intersect. So having understood this, let's consider a typical example. So let's take this example. In example 1, we are going to use mesh analysis to determine the currents I1, I2, and I3. Now to solve this problem, the first thing we need to check is if we have a current source in only one mesh. Now the answer is no, we do not have a current source only in one mesh. The second thing is to check if we have a current source in between two meshes, and the answer is yes, we have a current source between mesh 1 and mesh 2. Hence we are going to eliminate this whole branch. We are going to create a super mesh eliminating this whole branch. So we are going to eliminate the branch where we have the current source in series with the 1 ohm resistor. So let's redraw the circuit. So we have the 6-volt source, so we have 2 ohms, 2 ohms, 4 ohms, and then 8 ohms. And we have this to be mesh 3, so I3. And in our minds, we still have I1 and then I2, that is mesh current 1, mesh current 2. So we have this to be mesh current 1, I1, and then mesh current 2, I2. So we are going to apply KVL to this particular circuit, this new circuit. So applying KVL to the supermesh, applying KVL to the supermesh, we are going to take this loop. We are going to take this loop. So we have the source voltage, which is 6, is equal to the sum of the voltages dropped across the loop. Now, moving through this direction, in this branch, we have I1 moving in the clockwise direction, and then we have I3 moving in the anti-clockwise direction. So we have I1 moving this way, and then I3 also moving that way. So we have the two currents opposing each other. So we are going to have 2 into brackets, we have I1 minus I3, that is for this branch, and then moving this way, we also have I2 moving in the clockwise direction, in this direction, and then I3 opposing the flow of I2. So we are also going to have plus 4 into brackets I2 minus I3, and then in this branch we only have I2, so plus 8 I2. Now let's expand and then simplify this equation. So we're going to have 6 equals 2I1 minus 2I3 plus 4I2 minus 4I3 plus 8I2. So we still have 6 equals, we are going to have 2I1, and then for the I2s we have 4 plus 8, which is 12, so 12 I2, and then for the I3s, negative 2, negative 4, so minus 6 I3. We can divide through by 2, so we have 3 equals I1 plus 6 I2 minus 3 I3. So let's call this equation 1. Again, applying KVL to mesh 3. So for mesh 3, we are going to have, we know that the source voltage is 0. We have the source voltage to be 0, so that is equal to, now we have current I3 flowing in this branch, so that is 2I3 plus, we have I3 taking the clockwise direction, and then I2 taking the anti-clockwise direction, so that becomes plus 4 into bracket I3 minus I2 plus, also in this branch we have I3 moving in the clockwise direction, and then I1 also moving in the anti-clockwise direction, so the two oppose each other. So we have plus 2 into bracket I3 minus I1. Let's expand and simplify as well. So we have 0 equals 2I3 plus 4I3 minus 4I2 plus 2I3 minus 2I1. Now let's simplify further. So we have 0 equals, for I1 we have negative 2I1, for I2s we have only negative 4 I2, and then for the I3s we have 2 plus 4, which is 6, plus 2, which is 8, so plus 8 I3. We can simply divide through by 2, so that we have 0 equals negative I1 minus 2I2 plus 4I3. Let's call this equation 2. Now looking at the two equations, we have 3 unknown variables, I1, I2, and then I3. We need to do something about it. Now even before that, let's come back to the initial circuit diagram. We can apply KCL at this node. Here we have 3 amperes approaching the node, we have I2 also approaching the node, and then we have I1 leaving the node. So we can say that the sum of current entering is equal to the sum of current leaving. So leaving, we have I1 equals entering, we have 3 plus I2. So 3 plus I2 Now we call this equation 3. Now what we are going to do is to put equation 3 into equation 1 and equation 2. So we put I1 into equation 1 and equation 2. We want to eliminate I1 in the two equations. So for equation 1, we have 3 equals, now in place of I1 we have 3 plus I2 plus 6I2 minus 3I3. So we transpose 3 to the left hand side. 3 minus 3 is 0. So we have 0 equals 7I2 minus 3I3. Now we can transpose negative 3I3 to the left hand side so that we have a positive value. So 3I3 equals 7I2. We divide through by 3 so that we have I3 to be equal to 7 over 3I2. Let's call this equation 4. Again, for equation 2, we are going to insert I1, or better still, we are going to plug in I1. So we have 0 equals negative I1, which is 3 plus I2 minus 2I2 plus 4I3. So we have negative 3 minus I2 minus 2I2 plus 4I3. We transpose negative 3 to the left hand side. We have 3 equals, this becomes negative 3I2 plus 4I3. Now let's call this equation 5. Now the next thing we are going to do is to put equation 4 into equation 5. So for equation 4, that is I3 equals 7 over 3 I2. And then for equation 5, that is 3 equals negative 3 I2 plus 4 I3. That is equation 5. So we are going to put equation 4. We are going to put equation 4 into equation 5. So for equation 5, we have 3 equals negative 3 I2 plus 4 I3. Now in place of I3, we have 7 over 3 I2. Now because we have a fraction here, we can do away with the fraction by simply multiplying each term by 3. So we multiply each term by 3, by 3, by 3, so that we have 9 equals negative 9 I2 plus 4 times 7 is 28, so 28 I2, and then we have 9 equals, now negative 9 plus 28 is equal to 19. So we have 19 I2, we divide through by 19, and then we have I2 to be equal to 0.4737 amperes. So this is the value of I2. Now we can put I2 into equation 4 to find I3. So we have I3, or better still, let's say from equation 4, we have I3 equals 7 over 3 times I2, 0.4737, and that is equal to 1.1053 amperes. So we have I3 to be equal to 1.1053 amperes. Now let's go back to the previous page. So from the previous page, we had equation 3 to be I1 equals 3 plus I2. I1 equals 3 plus I2. So from equation 3, we had I1 equals 3 plus I2. So we can simply find the value of I1, which is equal to 3 plus 0.4737. And then we have I1 to be equal to 3.4737.